Hey everybody, my name is Ben Busby. I think most of you know that. I work as a principal scientist at DNA Nexus, where I'm also the chief happy hour officer. You can talk to me about that later. A lot of the slides here were made by Ted Ladaris, Anastasia Sedlikova, as well as Brenton Pyle. So thank you to them. And really, I'm going to talk. I'm going to give a really super fast overview to the UKBioBank Research Analysis Platform. I was talking to some people earlier. If you're using UKB and you're not using the analysis platform, I'd highly recommend it. It's subsidized by AWS. You can keep all your data in one place. And at the end of August, you're not going to be able to take any exome or genome data off of the UKB. So why not just use it in the wrap? It really makes a lot more sense. We'll talk a lot about Docker in case you want to compare things to Docker and WDL, actually, in case you want to compare things. Tiny bit about Nextflow. In case you want to compare things to all of us, decode other large projects. So, and that's what we're all really trying to do here. Also, we have webinars all the time on all kinds of stuff, including Docker, WDL, etc. So come check them out, especially if you're going from thing to thing. So I work a lot on the sort of scientific strategy for the UKBioBank, and the really cool thing is as most of you probably already know, there's massively multimodal data. Single cell is coming in 2023. I'm personally extremely excited about that for 5,000 people. So that's going to be awesome. There's a couple of things you might not know. If you go to community.dnanexus.com, you can sign up for like it's the community. It's sort of like Stack Overflow or BioStars for the UKBioBank wrap. Thank you to Istvan Albert. He was really nice at helping us set that up. Really a great guy. If you don't use BioStars either, you should check that out too. So that's really nice. And then if you want to like check out webinars and whatnot, you can do that. And a lot of them are more generally applicable than just the UKBioBank. If you're interested in learning how to do phasing or whatever, like that's a fairly straightforward thing, or integrate phase data with other types of data, that kind of thing. So also, if you're from a developing country or you're an early career researcher, you pretty much use the research analysis platform for free. And so basically, you can apply for credits from AWS, get credits to use that for free. If you want to get UKBioBank data for free and you fall into one of those two groups, you can do that as well. So just Google around for that. You should be able to find those programs. So hopefully that is super useful to you. Finally, I don't have a slide on this, but DNA Nexus is hiring. DNA Nexus is an awesome place to work. You can do computational biology 40 hours a week. It's with a lot of smart people. So that's a cool thing. If you're interested in working at DNA Nexus, please talk to me afterwards. All right, awesome. So I don't know if you've seen a talk by me before. If you haven't, I have 165 slides. So we're gonna roll through this. I was going to do a live demo. This platform doesn't allow that, but I can give you a live demo afterwards in a bar, coffee shop, whatever you want to do. So that's totally fine. So yeah, so ways to interact with the wrap. I'm going to kind of go through all of these at rapid fire. But then I also want to show you how to port your stuff onto the wrap and share it with everybody else. In that community space, there's a tools section where you can plug in Docker Hub links, GitHub links, that kind of thing. I'm going to move this microphone away slightly because I think the whole convention center can hear me. Really, and if you're watching virtually and it's too soft, just open a window. So anyway, right. So you can go to the community, you can put stuff up. So building apps on DNA Nexus will start at slide 80. So the next 74 slides is just walking through what the research analysis platform is and how to use it. Okay, so and really there's a cohort browser. That's awesome, something I've always wanted to have. But you can also interface with Jupyter Lab using Spark or not using Spark. So I think all of you probably know what Jupyter Lab is, so I'm going to gloss over this very quickly. There's web interface. I can run R, Python, so on and so forth, these notebooks. So that's really nice. And I have toolbars that control things in the Jupyter Lab interface. This is all built into the research analysis platform or RAP. But we also have Spark backing that. So if you want to slurp a lot of data out of the UKBioBank, that's fine. Taking a step back, what is the UKBioBank? It's 500,000 people, all of their medical records, exomes for about 470,000, genomes for about 200,000 so far, soon to be 300,000, plus 40 million medical images. Also things like ECGs, lipoproteomics, also known as metabolomics, and carotid ultrasounds, all kinds of other things. So it's about, eventually it'll be about 40 petabytes of data. So that's pretty exciting. But again, if you're using large cohorts, you're interested in a common disease like diabetes or something, you're probably going to want to use Spark-backed notebooks, even to slurp in relatively small cohorts, because it's a ridiculous amount of data. But if you're doing relatively small things, or not like slurping in bulk data, you can use single JupyterLab notebooks. That works just fine, and we do support Stata. Also, we have single JupyterLab notebooks for machine learning, and you can run those on whatever instances you want. So if you're interested in GPUs, my friend George works for NVIDIA. You can ask him too. He's around somewhere. That works really well. And if you need TensorFlow, whatever, that's all there. But you can also use Spark. That's really nice. We have an API called DXData, and then you can use Hail, whatever you need, to do large-scale things. And we've been working with all of us to make Hail notebooks that'll work on all of us, as well as UKBioBank. So some of you are nodding, so you know what I'm talking about. That's great. So basically, yeah, using the cohort browser, which I'm going to show you in a minute, you can build some cohorts, export cohort fields, et cetera, and then look at everything in JupyterLab. The nice thing about using Spark is you can go straight into a data frame, and then for those of you who don't know, you can go from a pandas data frame to R using RPy2. It's kind of a useful trick. The cohort browser is really nice. So basically you click on a data set, whatever you have access to, and then you can expose most of your phenotypic variables as tiles. So you can see them and you can filter on them. So if I want to do something, so I can filter by sex, or I can filter by lots of other things, right? So that's really nice. So if I want to filter and say I'm interested in all women between 61 and 70, who have breast cancer and take cod liver oil, that's a trivial thing to do. I can do it in the GUI, and then I can slurp it into a Jupyter notebook quickly to do further analysis. Or I can save that cohort, and then what I can do a GWAS right on there, and I can run an app. I have Regini, I have Plink, I have a whole bunch of apps where I can run a GWAS, or even a FEWAS, and I'll talk about that a little bit later. So if you want to launch a JupyterLab instance, we have lots of fancy tools for that. Like I said, one thing to point out is that you can run on pretty much any size instance that's available on AWS. So whatever you want to run on, you can do that. And the nice thing is it'll tell you what the price is. So this is pretty big, Stata, notebook, or whatever. It'll tell you how much it's going to cost for however long you want to use it. So the price is pretty transparent. And like I said, it's less than bare metal AWS. So it just sort of makes sense to use this fancy thing because it's free to you. So anyway, here you can monitor JupyterLabs. They take 3 to 5 minutes to launch because they run on their own ephemeral instance, and you can open it up, right? So that's pretty cool. Working with JupyterLab, we have open demo notebooks here at github.com, DNA Nexus, Open Bio. So there are samples for using these APIs, grabbing things with Spark, so on and so forth. If you need me to email any of this to you, I can, but if you just go to community.dnanexus.com, there's lots and lots and lots of documentation on everything I'm saying. So that's pretty useful. And so here I can use, remember I'm running these on an ephemeral instance, so I got to grab the data, and then when I'm done analyzing things, I want to send it back up. There's also a snapshotting capability, which is kind of nice. So understanding how to do that, I have project as storage, which is effectively in an S3 bucket, and then I have this ephemeral instance running the JupyterLabs. I can set a duration when I start, but I can also update that duration. So that's a pretty easy thing. And then so basic workflow is I might load a data file, read it with CSV. If I'm not using the Spark API, that's fine. Perform analysis, and then just re-upload it to my project. So that's a pretty easy thing to do. Here's a schematic of that. Again, I can make snapshots. That's like a DNA Nexus specific feature in JupyterLab. It's really quite nice, and then I can launch from those later. So it makes it really easy in terms of usability. I can, again, this is how you relaunch one. So if you're interested in doing that. Here's a diagram of kind of how Spark works. I won't belabor this point. It probably doesn't matter to some of you. Here's a diagram for how to run Spark. By the way, if any of you want to take pictures of my slides, that's great. If you want to put them on Twitter, that's even better. Just, yeah. Anyway, so then I can run Spark notebooks. That's really nice. As I mentioned a few times, there's this DX data API where I can go ahead and grab them. So that's, or I can go ahead and grab the data, port it into my Jupyter notebook into a data frame. So I find that really very useful. And so just to remind you, here's how UKB data looks. You basically dispense data from your application ID. That's pretty useful. And then you have these subject IDs. So the only really anonymization that we do with UKBioBank is that your subject IDs, your EIDs, are all randomly generated. So basically, if you tried to cross one project with another project under a different application, it would not work. So everybody should be under the same application. That said, in the wrap, I mean, you can onboard everybody that's in your UKB application, but that's a major advantage. I don't know how many of you have ever tried to get like 30 users onto a university HPC, but it is a waking nightmare. Whereas like this, it's absolutely trivial, right? So like once everybody's in your UKB application, it's trivial to add everybody to your project and you can all use it together. So I'm going to make fun of HPCs a little bit more later because about half of you left. All right, so yeah, and then obviously you can use Pandas data frame. Did I freak you out there? Just kidding. No, yes. So anyway, yeah, so obviously you Pandas data frames, Spark data frames. What you're often going to do is, churn on lots of data in a Spark data frame and then convert to Pandas. I think pretty much all of the Python people in this room use Pandas to some extent or some derivative of that. And we can argue later about whether Koalas is actually a derivative or something completely different. But that's kind of how that works. So if you haven't caught anything I've said so far, it really doesn't matter because Jupyter Lab is only one way to use DNA Nexus. The other sort of concept that I want to introduce you to are apps and applets. They're executable data objects, right? So DNA Nexus was originally designed, and still many folks use it this way, to process massive amounts of genomics data, right? So, and you can do that super efficiently by using apps because they spin up ephemeral instances, process whatever you want, and then spin things down. And anybody can build whatever they want into these apps, including you. So that's kind of the general idea here, is that you get the efficiency of these super ephemeral instances. So applets are visible. They live in your project. You can pass them around to different projects. You can git clone them and then build them, whatever you want to do. Apps can be shared between projects, so you can make more general apps and share them with lots of people. But you can also just put applets on GitHub and people can build them themselves. And that's actually what I'm going to go over in the second part of this presentation, starting in 13 minutes. Okay, so applets and apps are built the same way. And you just say whether you want it to be an app or an applet. That's sort of a minor point. And then we have workflows. The really nice thing about DNA Nexus is that you can build workflows in the GUI if you want to do that, and it's fairly trivial. A really nice thing is you can do pretty much all of the stuff that you can do in the GUI in a command line, and all the stuff you can do on a command line in a GUI. So if you're collaborating across a bunch of teams, which we've talked about a little bit before, it's really trivial to do. So that's really nice. So if I want to run an app or an applet, I can just grab that. So this is like for if you have people on your team that are sort of more general users, you can do that. Feel free to put that slide on Twitter if you want. Okay, and so you can select an app from the tools section. You can see all the parameters and so on. They should all be modifiable. And actually, when you build apps, you can make them modifiable for users of your app if you're interested in that. So, and then you can specify, put things in there, so on and so forth, all of that. Change instance types. So if you want to run something faster, that's useful. For those of you who don't use cloud infrastructure a lot, usually you want to run faster on cloud. Typically, it doesn't matter. And so storage does cost some money. Although in the RAP, the UKB research analysis platform, you're not paying for storage of UKB data typically, so things run quite fast. You can monitor jobs. So there's a whole bunch of provenance, but you can also monitor running jobs. You can view logs. That's really nice. And actually, you can spit those logs out using the CLI. So you can spit out standard out, standard error, that kind of thing. Super nice. Also, so we have tutorial videos about a whole bunch of things, including the command line interface, and you can run apps from there. So if you pip install DNA Nexus, which is just pip install dxpy, then you have a command line interface to DNA Nexus, which will work with the UKB wrap. So basically, you dispense your project on UKB wrap, type pip install dxpy. It'll take a couple hours to dispense your data, but other than that, you're up and running on the command line. So that's a really quite a nice thing. And then you can run any of these apps, like the ones I was showing you with the GUI. You can run them on the command line. So that's a super nice feature. You can either run them interactively or not. And if you find the app description page, you can find the exact name. That's useful. There's command line usage variables, et cetera, et cetera. And you can change instance types in there as well using the command line. And then you can monitor your own jobs. So that's a useful thing, so on and so forth. And users of apps you build or workflows you build can do all these things as well. You can also run apps in batch. So say I want to process something on 200 VCFs or 2000 VCFs, I can totally do that, basically plugging in an array of file names. And then I can run that way. So that I find that super useful. There's a hard limit of 200 concurrent jobs, but if you email support@dnanexus.com and say, can I have more space, they will give you more space. So I think you can go up to 700 or 800 without doing anything super special. So if you want to do that, that's cool, but obviously just be careful. Don't do anything crazy and run up a huge bill where you or your PI, depending on whether your PI will get angry at you. And the worst thing is to get angry at yourself. So just be careful, run test jobs before you run 2,000 things. We all know this, and we all violate that rule all the time. So and in our science corner, we have guides to analyzing large sample sets. And actually, I told my friend Martin that I wasn't going to talk about HLA at all, and I lied because here it is. So anyway, there is a mention of HLA in here. Also, if you want to know anything about HLA, you should talk to Martin. He's sitting in the back. Okay. Anyway, and then also there's this concept of workflows, which I mentioned very, very briefly. And so what are workflows? I have a whole bunch of apps strung together, and I can build these in a variety of ways. I mentioned I can build them on the GUI and just like literally string them together by putting output of one into another. I can run bed tools and then put that in, on a VCF, or sorry, on a FastQ, and then on a BAM is what I'm trying to say, and then move that to something else, so on and so forth. So there's these native workflows, but I can also port in workflows from WDL or CWL. So we have a standalone compiler. If you Google for DX compiler, it's all on GitHub, although you can download binaries as well. So that's really quite nice. We'll talk about that a little bit later. So here I have workflows. I can tune my workflows if I'm running them, that kind of thing. And we're going to talk a little bit later about building workflows using Docker and WDL. And it's basically the same as running an applet. So here, basically, I'll just run workflows. This convert a VCF and run Plink. That's something a lot of people would want to do. All right, so that is how to run anything on DNA Nexus in 20 minutes. Are there any questions before we move on? And specifically looking at the research analysis platform. And really, I could stop here for a few minutes and take any questions that you have. It's a good sort of break time because after this, we're going to pivot into building everything I just showed you. Yes?
Thank you very much. So for the biobank, is it public? There is no need to sign any agreement to get the data?
So the biobank, so UKBioBank is a registered charity in the UK, which has all the data I mentioned before. So the 500,000 people, so on and so forth. So you do have to apply for data access with them. Again, that's with the UKBioBank directly, not with DNA Nexus. they will go through the process of vetting you as a researcher, and then you pick the data you want and all that. It is not a scientific grant in the sense that you don't have to justify your science to them. You are ensuring to them that you are doing responsible science and that you will take care of people's patient data, because it is not anonymized except in the EID scrambling thing I showed you before. So that's important to note. But again, something I really want to emphasize: if you're an early career researcher or from a developing country, you can get access to the data at a reduced or free price, and then you can process the data at a reduced or free price. All of that is subsidized by both the UKBioBank organization as well as AWS.
Okay, so you suggest to get the data first, then we can ask.
Absolutely. So this is a free layer that basically sits on top. So you would apply for the data through UKBioBank. Then once you get access to the UKBioBank data, it's very, very simple to dispense that data onto the research analysis platform.
Okay, so here in the United States, what other examples like UKBioBank we can use here?
So in the United States, another project that is somewhat similar in concept to the UKBioBank is the All of Us project. The All of Us project aims to have 1 million individuals, but they're a number of years behind the UKBioBank project. So they're just starting to get their first 100,000 online, and they don't have as much phenotypic data, but also they don't have they don't have as many people, but also UKBioBank has, I believe it's 14 years of phenotype history, which All of Us does not have yet. Although, I mean, it's very promising that there will be some. And then there's also, and there are ways to apply for that data. There's also the Decode project from Iceland. I'm not as familiar with that one, but there are, I believe, ways to apply for access to that data as a researcher.
Thank you very much.
Absolutely, sure.
Hey, thanks a lot for the talk. I'm half up right now. I have a question about like the pricing. So do you just pay for each app that you use, or for the duration the app runs, or how does the pricing work?
Yeah, so I mean, the Jupyter Lab will tell you right up front what the price is. So you say, I want to use this instance or this set of Spark instances for 4 or 5 hours or whatever, and it will tell you right there, this is going to be £2, whatever it is. In terms of the apps, they run on an ephemeral instance, and they're actually way more efficient. They're designed to be extremely efficient because basically they run on a server that is sized to run that particular thing most efficiently. And as I'll talk about in the app development part of this discussion, really you set a default for that, or the developer sets a default for that. So if it's your app, you kind of probably have a sense of what size server you want to run it on. That said, it runs more efficiently, but you're always going to want to do tests. Now, I showed you the sort of monitor area. In the monitor area, for every job, it will tell you how much money you've spent so far, and then at the end of the job, it will tell you the total cost. So basically, you want to run some process on a couple thousand VCFs, right? You want to take a representative sample of 2, 3, 4, run these processes on them, and make sure that the cost is appropriate, and then you scale it up. But like I said, it's a fraction, not a tiny fraction, but a fraction of what sort of commercial retail cloud is going to cost. So yeah.
Thank you.
Absolutely, yeah.
Hi, great talk. So I have some questions about what kind of data can you download to your native system from bioinformatics, like tertiary analysis, meta-analysis kind of, can we download that kind of data?
Oh, great question. Yeah, so I mean, from the UKBioBank, you can still use the UKBioBank to download the phenotype data, for example. So that's the primary data you can still download, right? And that's part of your material transfer agreement with the UKBioBank, right? So you don't need the wrap to do that. Then again, if you're doing any significant data processing, why not? Also, then you have all these fancy bells and whistles for being able to use that data and slice and dice on it. And I didn't show you, but there's also a genomic analysis part where you can look at minor allele frequency for any of those cohorts. So I was talking about, women of a certain age with breast cancer. You can look at minor allele frequency in that cohort versus the general cohort. So that's a really like fancy, like one of those bells and whistles types of things. That's really quite nice to use.
Right. So, like as an example, if you run like some GWAS, like let's say region or link on some some phenotype, and can we download like summary statistics from that and like work without?
Yeah, I mean,
You can do that, right?
so you would have to consult your material transfer agreement, but you know, I mean, anything you're about to put in a paper, right? Like summary stats that you're going to publish. Of course, that's the point, right? I mean, you know, we want this science to be communicated. So and really, I mean, I am not a legal expert, but I would say the generally agreed upon line there is, you know, I mean, you have to use your judgment as a scientist, but what can be re-identified, right? If it can't be re-identified, if it's summary statistics from a GWAS, you should be good, because the whole point, again, is to take those SNPs that you find in your GWAS and share them with other members of the scientific community.
Right. So another question about like phenotype data per se. So you know, for some common outcomes, you have like different kinds of tables, like hospital inpatient and primary outcomes and first occurrence table, death registry, and things like that. So usually we have to kind of parse through all of that to compute a phenotype per se, right? Or rather like define it. So is that already done in RAP?
I have really good news for you. So one other thing I wanted to say about your last question that I forgot to say is that there's a part of UKBioBank, if you do any large scale research, they ask that you actually return that data so it can be indexed and parsed, right? And so actually, it turns out that the hospital data is actually all pre-coded, right? So for example, you have ICD-10 for everybody that went into a hospital. However, previously, the primary care data was not pre-coded. And the reason is because in the hospital data, there were 4 million diagnoses, but in the hospital or in the primary care data, there were 200 million diagnoses. So for one thing, it doesn't come in the cohort browser thing that I showed you. It actually comes as bulk data because it's so huge. And it's not previously pre-indexed by the NHS. That said, now it is. So it's really nice because you can get sort of basic NER extracted, and you can get, I'm blanking on all of the fields you can get, but you can basically get a summary of the data with ICD-10 codes, as well as a couple other basic summaries of the primary care data and basic summaries of what is in the clinical notes. So that's really nice. But if you're an NER NLP expert and you really want to parse the clinical notes yourself, you do have access to that data if you request it from UKBioBank.
Thank you.
Absolutely, yeah.
All right, you mentioned WIBBLE. Will there also be Nextflow support at some point?
So there is Nextflow support already to some extent. So I didn't mention, but if you can have these ephemeral Jupyter Lab instances, but also you can have, there's two ways to launch ephemeral workstations. So you can launch, there's something called TTYD. You can also launch basically a vanilla Ubuntu instance of any size you want. So you can run Nextflow on those, obviously, but also we've wrapped some of the NF core pipelines such that they will run as efficiently as possible on one instance. Then coming soon, there will be the ability to run, we've worked some with Paolo. I don't think that's a secret at all. Actually, it's not. We made a webinar about it. So we worked some with Paolo to make instances be able to call it other instances. So you'd be able to really do super large scale stuff on Nextflow. That said, most of the users I talk to, they think they're doing huge data processing with Nextflow, but they're actually doing sort of medium-sized data processing on Nextflow. So like you can just launch a few 96 core machines and do what you need to do. Like I think there are a lot of people, myself included, who really sort of overestimate how much compute they need to do what they want to do. And that's something I see a lot with Nextflow because it's really pretty efficient. So yeah.
Thank you.
Absolutely.
At the time check, you've got 25 minutes left.
That's totally cool. You know what? I'm here for the questions. Like really, I'm here for you guys. You want me to answer questions the entire rest of the time? I can put the video up in the comments and you guys can watch the rest of the video. So really, yeah.
Question about the lab environments. So for Python, if you're installing packages and stuff, is that persisted? And then do you guys use environment managers like Conda, or you just kind of pip installing?
So yeah, actually, Conda is already supported there. It is not in the cloud workstation, so but you can ask Fritz over there. We use Mini Conda all the time to install stuff on cloud workstation. But anyway, yeah, so Conda is supported in the Jupyter Lab interface. But that's the beautiful thing about this snapshot functionality. It will save all of those dependencies and everything you put in via Conda. Or like, for example, if you install like bioconductor or whatever, like all those things, those dependencies are saved. Or going back to the clinical notes, if you're still like an old school Perl programmer, you can, and you're using that to do text parsing, all of your Perl dependencies will be saved. So great, cool, yeah. So that's a really nice feature. So, all right, any more questions before we hop on to the second half of the presentation? Okay, gotcha. Is anybody bored? Because I can go faster. Just kidding. All right. So anyway, all right, awesome. So yeah, we'll talk about app development and how you would actually build these things, because that's one of the really nice things about DNA Nexus is that any developer really can build their app on DNA Nexus, and anybody can really build anything that they have a license to use. So and if you are building stuff and you want industry people to use it, please, please, please use MIT or Apache or BSD3. If you start using other funky licenses, then people kind of freak out. So, and if you want to have a discussion about licensing, please talk to me. I'd love to talk about that offline. Let's restrict that as the one thing we're probably not going to talk about online. Okay, great, cool. All right, so anyway, so yeah, basically you can git clone whatever you want, package it into an app, and build it on an app or an applet and build it on DNA Nexus. What is an app or an applet at DNA Nexus? Basically, it's a script file, be that a Python script or a Bash script, wrapped with JSON files. So super simple, super easy contextually. Let me show you an example. So we have this app called Swiss Army Knife. It's got all kinds of stuff. It's got Regini and Plink and blah, blah, blah. But it also lets you test things out with Docker. That's really nice. And if you're doing some basic image analysis, you can just pop Docker in there and then run your image from the GUI. Although all of our virtual sort of command line stuff, that also runs Docker. So if you're a Docker person, that works out well. But with Swiss Army Knife, with this tool that does all this stuff, you can basically run whatever you want straight out of a Docker image. That's super convenient. As I'll show you in a minute, you can do this in the apps too. But basically, we have a wizard for building the apps. So here's the nice thing. You don't have to create a JSON file. It creates the JSON file for you and a whole file structure backing it up. So that's a really, really nice feature in my opinion. So let me show you an example. So say I'm going to build a SAM tools account, then I can just I can build that on here. So if I'm going to use the app wizard, basically I type dx-app-wizard, and I'm going to put some basic inputs in there, like what's the name of my app, so on and so forth, and it's going to make this directory structure. And the nice thing is, so it basically makes a bash script for me, as well as this wrapper JSON, which basically will have my inputs and outputs and default instance types, as I was mentioning earlier. So again, I put the name, I put what file type, what types of input I'm putting in. So, if you're using some super specific adapter, might be a string, but usually it's going to be files. Put as many of these as you want. It just makes the JSON bigger. It's not super complicated. And then you have output specs. That'll upload your output automatically, which is super nice, from these ephemeral workers up to the S3 or for whoever's using your thing. So that's pretty great. And then I talked a little bit about data classes. Usually they're files, sometimes strings. You can also get other things. And again, you can enable these things to run in batch, so you can have people put in arrays if you want to do that, right? So they can basically put in a list of files. You can have access to the internet or not. That's the default is no, but if you're running live Docker, which you might want to do, then you can do that. Also, you can give it access if you have like an if statement that says, if something doesn't match, then grab this other reference genome. You need access to the parent project, but it really just depends on how worried about security you are. And then there's like templating options. I usually build things in Bash, but there's a Python template too, if you like that kind of thing. The nice thing, again, is that the app wizard generates the skeleton for you. The other nice thing is any DNA Nexus app, you can save it, and then you can add on to it, right? So anything I see as an app, the Swiss Army knife, anything else, I can save that at Regini, for example. I want to update the version of Regini. I don't have to completely rebuild it. I can just download the existing Regini, grab it, update it, and then rebuild it. So that's kind of nice. I'll go over that again in a second. So here's the project structure. And then I have this resources folder, so I can pop all kinds of binaries and dependencies in there if I need to do that. So that's super useful. If you are using this and you're grabbing DNA Nexus apps, you want to modify them to work on the wrap. Remember EU West 2. That's the region, that's the AWS region where all the AWS or all the UKBioBank data lives. This I mentioned like 3 times, but you can get applets or apps and then just make them a little bit better. All right, let's talk a little bit about executable scripts. So basically, this is the structure in all apps. You're going to download the data from your, essentially your storage. You're going to run whatever it is. So here, you're just running SAM tools, counts, blah, 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 and then you're re-uploading them, right? So super simple. Obviously, this can get as complicated as you want because you can put anything in the middle here. So if this is your application, you can have it run this and so on and so forth. If you have a workflow, you could theoretically put it all in here, but it's probably not going to be as efficient because the beautiful thing about having these things strung together in a workflow is that every single one of them can use a different compute node, right? So then like all of a sudden you're making your thing as efficient as possible because you have something that's high CPU and then something that's high memory and so on and so forth. So, but if you want, you can load everything in here. If you're doing a lot of GPU work, a lot of people will make one app just because CUDA has its own passing protocol and all that, but George is no longer here, so we'll skip over that. So here you can use bash scripts, so on and so forth. That's really nice. You can also call other scripts, that kind of thing, call your own scripts, so on and so forth. There's some stock helper variables. That's super nice. And then so basically what it does, you're downloading the files. I kind of went through this before, but to go through a little bit more explicitly, you're defining your output variable, and then you're running with a helper variable and storing the results. There's a template already there for you, so you don't have to like redo these like input and output things. Just put in your variables. So that's pretty nice. Also, there's some shortcut tools like DX download all inputs. And we have a couple standalone webinars on this. If this is something you really need to look at, no problem. And I got the slides from the people that built these standalone webinars. So then to build an app, literally, it's just whatever. You just come out of this directory structure one level and type DX build. So that's it. And then, bam, you build an applet. It works out pretty great. And it pops it into that GUI space. So if you have GUI users or whatever, they can use it. Or say you're building apps, you provision this on GitHub.
15 minutes or so.
Oh, cool. Okay, thank you. So you can provision this, put it on GitHub. If somebody has a computational biologist in their group, they can just, or somebody even a little bit compute savvy, they can git clone it, they can build it, and then the people that are only used to the GUI in their group can use it, which is super cool. I mean, I think that sort of democratizes computational science. I am not, however, advocating that we just have people willy-nilly come running like GWAS without covariates and stuff. That's a terrible idea. Don't let anybody do that. Okay, everybody's smiling and laughing again. So clearly I've hit a nerve one more time. All right, although we do, if you are a computational biologist, we do have some notebooks for automatically generating covariates. And I think that's super cool. And I love talking about covariates. So if you want to have a discussion about that later, I'm around till Thursday. Okay, awesome. So let's talk about some more custom things. So Docker images are super useful, particularly when you're building apps. And there's basically two ways to use them. You can use Docker save and then make them into like an asset or a reusable resource, or just pop them into resources. Or you can actually just run Docker from within the app. Sometimes it's more efficient to do one, sometimes it's more efficient to do the other, just depending on how long it takes to grab your Docker image from the how long it takes to initialize the run of your Docker images. So you can do all of that. Also, it depends on reproducibility, right? If you're running a sort of super specific image and whether it's still going to be there, so on and so forth, and whether it belongs to you. So there's all of that. So again, you can just grab the image, you load it up, and you can run it. So, and you can see here, I'm just using Docker run. And by the way, all these slides will be available, so you can copy from any of these templates that you want to. It's pretty simple. Like I mentioned, we have Cloud Workstation and this TTYD thing to prototype Docker apps. So they're really easy to use. Again, you can use Swiss Army knife as well. Here's a minor footnote about access permission. So as all of you know, Docker works quite well in the cloud. It's pretty easy because usually you own your own stuff, as opposed to an HPC. One person left that time. Okay, so anyway, so yeah, and you need to compile in the same operating system. That should be pretty obvious. Oh, when you put in binary executables. Yeah, so those you put into your resources file too. I also often encourage people say, well, I'm an R user. And I'm like, well, you can use that in Jupyter Lab, which is useful. But also you can put these into apps. And I think that's pretty useful. So you can build sort of like really efficient little ways, compartmentalized ways to run your R scripts. And I think that's nice. And if you can imagine, you can run a whole bunch of R scripts sort of in serial on different CPU environments. And so that's kind of an easy way to get efficiency without sort of leaving R. And I think that's kind of nice. And I know somebody's going to come up to me later and say, but no, I can run R efficiently. And I'm going to say, that's awesome. You should come work at DNA Nexus. So anyway, there are other people at DNA Nexus that run R efficiently too, but then you could be a colleague of theirs and all of you could work together, which would be great. So anyway, all right, so let's talk about building some workflows since I have 13 minutes left. Okay, so we have this thing called GL Nexus. By the way, GL Nexus is available on GitHub, and it is a way to be able to integrate massive numbers of VCFs and create very, very large GVCFs. Mike Lynn built it, who also retweeted the fact that I'm giving this talk. So he's out there somewhere. I believe he lives in Hawaii now. Anyway, so yeah, so I can combine many VCFs using GL Nexus and then annotate with SnpF. By the way, I also give variant annotation workshops. If you're interested in talking about variant annotation, we should talk later. Spoiler alert, Google Open Cravat. It's awesome. Anyway, okay, so that was an aside, by the way. Nothing to do with this talk, exactly. So yeah, I can build these workflows by adding tools. So say I have a whole bunch of tools on DNA Nexus, these apps, I can connect them like this. I've mentioned this 3 or 4 times. You can paste them together. This is kind of nice. Theoretically, you can do this on the command line, but you know, I'm a command line person, but honestly, this is so easy. I don't do this on the command line. Like that doesn't make any sense, right? Like why wouldn't I just drag and drop something? So that's kind of nice. But if I want to use something like scatter gather, right? Like WDL is amazing because I can take a WDL workflow, and I'll show you an example of this. I can take scatter gather or CWL. We talked about Nextflow at length. We're going to talk about Nextflow all the time. I'm going to text Evan and tell him that we're talking about Nextflow, which will make him very happy. By the way, is Evan here? Does anybody know? No? Okay. Anyway, and then, yeah, so, and then if you have a script, you can create an applet out of it or just use it in the Jupyter notebook. So that's kind of nice. Yeah, so those are all things you can do. Most of you probably know what WDL is. I saw a lot of looks of recognition looking up at WDL. So if you're used to that, again, there's a compiler that's really nice and it's great for reproducibility. These build into native DNA Nexus workflows. They're really pretty. I'll show you in a minute. And there's lots of stuff out there, BioWhittle, so on and so forth. If you do any collaboration with the Broad, there's lots of Whittle things there. So running Whittle on UKB app, the nice thing is, or on UKB wrap, you can create tasks, workflows, etc., and it tries to do compute optimization for you. So that's a plus. For debugging, here's some suggestions. Again, these will be available to you. I'm not going to dive into this. And then basically there's a compiler in Java, and you just run it. It's really quite nice. Compiled workflows in Whittle go on the GUI as well, so that's really nice. People can see them. They can move things around. So again, if you're developing a software program or you're a computational biologist in a lab, you have a bunch of folks who are not so computationally savvy, or they just don't want to be computationally savvy. So you can enable them to use the GUI on that stuff, which is great. Works really well with statisticians. And if any of you are statisticians, thank you. Gotcha, thanks. Okay, so, and this is what a compiled Whittle workflow looks like on the platform, so that's really quite nice. As you can see, it's got the same bells and whistles GUI that all the other stuff does, so that's great. And then here is basically a Whittle workflow mapped to those specific places. And then here I promised I would talk a little bit about scatter gather. So really this does that kind of thing. That's really quite nice. So to use scatter gather, so it'll shoot out a whole bunch of other ephemeral instances. I'm going to talk for a few minutes about Docker before we get to questions. So Docker solves a lot of problems. I know a lot of folks would like their, biologists really would like the stuff that they've painstakingly gotten to onto an HPC, would show up on the cloud. You can make this happen for them by wrapping everything in Docker. I assume most people here know how to use Docker, so I'll skip over what it is. Obviously, lots of public registries, and in Docker Hub, you can port things over. So that's really quite nice. And you can use Docker in Whittle. Actually, it's really a great way to do that. Everything kind of has to be either in Docker or built as DNA Nexus apps. That works out well. And using the DX compiler, you don't have to specifically cite Docker. You can snapshot things using Docker save. That works out well. So with that, I'd like to mention that there's this community forum. There's a DNA Nexus newsletter. So really, if you're using the UKB wrap, or if you're building algorithms that you think are particularly good for population genomics, please join the community. Put them in GitHub, and then send links to other UKB users, because there are thousands of users who may want to use your algorithm. And so as the open source community, I think it's really a powerful data set, and it should be using the best algorithms that are out there. That said, thank you very much. I know it was just a little bit of material, and hopefully it filled the time in a non-boring way. Thank you for taking pictures. Once again, if you were taking pictures, please feel free to put them on Twitter. And if you are looking for a job and you understood half of this talk, please talk to me about working at DNA Nexus. That said, thank you very much, and I'm happy to take any questions.
We have a virtual one that actually is for your talk. So the question from HD Cross is, will DNA Nexus, the tool like you were speaking about, and this came in a little bit earlier, eventually be available to be used with the All of Us data?
So I would like it to be, and if you're communicating with the program officers around All of Us, please let them know that it should be. Right now, there are no plans to do that. That is on All of Us. But what I can say is that we are talking to several other large biobanks. So one thing that I would say is fairly certain is that UKBioBank will not be the only large biobank data set on DNA Nexus. There will be other very, very large data sets coming soon to the research analysis platform. Yeah.
Great. Another question about, can you run like proprietary, methods on DNA Nexus?
Oh, absolutely. Yeah. I mean, and there's a couple of ways that happens. I mean, we are a commercial entity. And so we're very used to that, right? Because I mean, I'm talking about the research analysis platform, which is for the UKBioBank, but there's actually pretty much everything you just saw. There's a commercial side too. So pharma companies and clinical diagnostics and hospitals use that. And they buy a lot of algorithms. And so there's a number of ways to market that. So basically, like say, for example, a simple example, and there's again, many ways to do that. If you wanted to sell something, you can wrap an app, you can lock the code down, right? So people can't just dump the code, and then require a license file, for example. And again, that's just an example. There's a lot of ways to sort of sell code. But yes, I mean, it is certainly possible to distribute code that you want to charge for through DNA Nexus. Happy to talk about that offline. There's a lot of considerations there, but let me know. Send me an email. By the way, it's bbusby@dnanexus.com, or just Google me, and happy to talk about those sorts of things.
Thank you.
Sure, yeah.
It sounded like you mentioned GUIs and being able to provide a user interface with your app. Is that possible? And if so, like what kind of GUI can you provide?
Absolutely. So all of that. So there's a sort of general DNA Nexus GUI, which looks kind of like this, right? So basically, folks can go in and they can put things in, and then they can configure the instance size and a bunch of put in their inputs, put in their outputs. This kind of GUI. So your app can be right here, right? So yeah, exactly. You wrap your app, and then it shows up just like this. And literally, they click on it, and then they can put it into workflows. So they can use SAM tools, and then whatever your thing is, and then whatever's next after that. Yep, or VCF tools or whatever.
Follow-up question on that. Does this GUI support the authentication and authorization?
Well, what do you mean exactly?
Well, let's say that I want to have bioinformatics to access the tool, but I want to make sure that they're authenticated, not just that anyone can access it.
Oh yeah, absolutely. So I didn't mention, but that's a big reason people buy. Like when people buy the commercial side of DNA Nexus, it's a big reason they buy it, because everything I told you about exists within a particular security perimeter. So like, yeah, I mean, like the whole shebang is inside like authenticated security, FedRAMP, blah blah blah, all of that. All of the resources I showed you sit inside there. Yeah. So, and then you can authenticate in a variety of different ways, through single sign-on, passing tokens, login, two-factor, all that. So, yeah.
So I guess that like Google ID is supported.
I don't know if Google ID is supported per se, but Okta certainly is supported. For some of the platforms, Google Authenticator is supported. But yeah, if you have a specific question, just email support.
They all use SAML too, right?
What's that?
They all use SAML too.
So personally, I am a computational biologist and not a security expert. So I think that's true, but I don't want to say for sure, because I don't actually know. Yeah. So, but yes, I believe you're right. They all use SAML. Any other questions? I always try to end my talks on questions I can't answer. It's just a reminder that we don't know everything. Cool. Well, thanks for coming. I mean, I know it's like a lot of me yelling at you from here, so I appreciate you guys like being able to stand through it. And yeah, hopefully I'll talk to most of you at some point. And again, if you want to come work at DNA Nexus, let me know. Cool. Thanks.